Hello again, this is Robert Veach from Vparanormal. I'm going to show you a device that I designed, and I'm calling it the K2 amp with SB7 Validator. Now we all are familiar with the SB7, the ghost box. It's called P-SB7 typically, and it's a scanning FM radio or a scanning AM radio, where you can scan channels at 100 milliseconds, 200 milliseconds on the AM band, 100 on the FM band. And you get various responses and syllables that come through. Now I feel that the way this is operating is it's getting very low EMF signaling that is coming through, being demodulated by the internal circuitry and producing audio that's not the radio stations. And you could typically test this by looking at the number of syllables that you get while it's changing channels. And you'll get a response over several channels, which validates it. Now we're also all familiar with the K2 meter. And this K2 meter here is the typical one that you buy, designed by Gary Galka. I also designed the SB7, Gary Galka. And what I have right here is just any Bluetooth amplifier that I'm going to be using, and then this is the device itself. This is the K2 amplifier with SB7 Validator that I designed. Now right off the bat, on the below the video in the information section, I have all the links to the components that you could use to build this, including the circuit board, the box, the LEDs, and so forth. And at the end of this video, there's going to be complete schematic of the circuitry so that you can go ahead and build this. Now the reason I built this is because if you watch some of the shows on television right now, they use geoboxes, called by several different names, a geobox, wonder boxes, and geoports. It's a good concept. They're putting validation to a scanning radio, and which is a good idea. What I don't agree with is that they use a spring reverb on the audio, which just adds distortion and audio elements that will make it hard for you to hear what's coming out of their scanning radio. So here I'm going to demonstrate audio-wise why a spring reverb I don't think is the right thing to use on a ghost box audio. So this is a investigation where I ask a question right here and get a EVP response here. So let's play it in its raw form first.
For paranormal groups to come back and to investigate further.
So this part right here is the EVP, and we think it's saying you guys want to flee or you guys want to fly. Let's play that again, the raw part right here. Now I'm going to put it through something that's equivalent to a plate reverb.
Investigate further. Investigate further.
So as you can hear, it kind of distorts it so that you really can't hear what it's saying, and then your pareidolia kicks in and you start to think it's saying something else. So I don't think the geoports or geoboxes and wonder boxes using those plate reverbs or plate springs is a good idea. So that's why I'm not implementing something like that in my design here. So I'm going to show you a block diagram of typically what's inside one of those geoboxes. And you see it's got an AM scanning radio. In this case I could use AM or FM. Signal amplifier, which is similar to what's inside here. Then it has a sending and a receiving unit through a coil. And the sending unit is typically a little transducer, like a little speaker. The receiving unit is a little receiver, like a microphone. And there's a physical coil between that. It's kind of like a coil reverb. Essentially, some of the early reverbs were just like that. I used to use those type of reverbs when I was building synthesizers many, many years ago. Then you have an EMF pickup amplifier driver, and then of course another amplifier, and then they go to a speaker. Now if you look at my block diagram for the K2 amplifier with SB7 Validator, you see that the K2 is being fed into an amplifier with a blue LED, a trigger LED, and it goes to an automatic squelch circuit. And then what goes into that squelch circuit is the headphone output of the SB7. And then you have a gain adjustment on that K2 amplifier, and then the output of that squelch circuit goes right to the Bluetooth amplifier. So there's no reverb placed in this, nothing to add more distortion, so that you'll be getting the syllables right out of your ghost box, the SB7, directly. So I'm validating what is coming out of the SB7, and it's being validated because the K2 has to have an EMF response for this audio to go through into the amplifier. That way you're not hearing all the radio stations, you're hearing minimal amount, and you need some kind of an event, some kind of an electromagnetic field event to actually hear the audio of the scanning radio, in this case the SB7. I have a power indicator and a triggered LED blue and a sensitivity knob right here. And you go counterclockwise, it's minimal sensitivity, and as you go clockwise it increases the sensitivity where you could actually get it to trigger for just ambient noise, electrical noise in a house. So you have a full selection there of where you want to set it as. Now one of the unique things about this is I'm calling it a K2 amplifier is that I have an audio tap on the standard K2 meter. And I'm going to have a link down below of the video that shows exactly how to do that. Very simple to do. You're going to tap off this K2 meter and you're going to get the audio from that. And that is what's going into this circuit right here. And it's actually amplifying the signal that comes out of this so that it's more sensitive, so that it's easier for whatever environmental change or whatever entity is present. It's easier for them to send a signal to the K2 to trigger the system to let the scanning radio through to allow you to hear it. Now that sensitivity, like I said, is fully adjustable right here, and you'll notice, I'll demonstrate that it'll start showing, triggering, before even the first green LED of the K2 meter. And that was my goal, was to increase the sensitivity. Now I'm going to turn on, I have the K2 meter turned on already, and I'm going to power, there's a power switch here, I'm going to power this. You saw the trigger come on, then it resets itself. Now I'm going to turn on the SB7, and I think I'm on the FM radio, and I'm going to put it on 100 millisecond scan. I'm going to increase the volume right here. Now I'm going to turn on my Bluetooth player. And I'm going to increase the sensitivity here. And you saw the trigger LED came on, and now you're hearing the scanning of the SB7. Now I turn the sensitivity down, and you see it turns off, the syllables are coming in. You have an adjustment right here. Now I'm going to trigger this and show you how it works. So right now this SB7 ghost box is scanning, but we're not hearing any of the syllables or any of the radio stations. If I take a magnet, you can hear some of the syllables coming through. Now notice that when I place this magnet near the K2 meter, that you're not even seeing the green LED come on, because I'm amplifying it so that it's easier to get a response. Now as another demonstration, I have just a magnet on a motor, and you can see how sensitive it is, and I can turn the sensitivity down so that I've got to come closer to the K2 meter to get it to trigger. Or I can raise the sensitivity so that it triggers really close to it, like that. So you have a full range of selection of sensitivity there, which you're going to need depending on your environment. If you're in a building where there's no EMF, there's no AC power, you're going to be able to crank this way up. Right now I can crank it up and then it'll pick up the ambient noise in this house. I had the washing machine turn on when I was testing this, and it let some syllables through because that was a big burst of EMF. Now I'm going to demonstrate something that's unique about this K2 amp and SB7 Validator. I'm going to increase the gain just to the point where it's about ready to trigger. Now the K2 meter is not really set up to measure something as small as a static charge. A static charge, a moving static charge that you move, will create a very small EMF, and this normally won't pick it up or display that. Now I'm going to charge this on my hair, and I'm going to place it by the K2. And as you notice, the syllables in the radio are coming through with just that small charge on this piece of plastic. So this allows you to be in an environment and pick up some minute EMF changes which could possibly be an entity trying to communicate through this system. And then of course if they can get some syllables through the ghost box, you'll be able to hear it. So this is why I'm calling it a validator, because it helps validate what you're getting out of the ghost box. And the validation comes from the circuit, the built-in squelch, and the amplified signal from the K2 meter. Again, I'm going to have schematics at the end of the video and a complete parts list available so that you could build this for yourself. I want to point out that these geoboxes, some of them run from $600 up to $3,200. And there's a lot of people that make different versions of them. So you could save yourself some money and go ahead and build this yourself. And you don't have to worry about the spring reverb, and what will come through will be clearer, and you will be able to interpret your SB7 scans and syllables coming through with this validator system. It's not hard to build. I took the circuitry and I reduced it to a minimal number of components, and the schematic will display those components, and the parts list will allow you to purchase these and build one of these for yourself. I think this is a great tool. I'm going to be testing it in the field, and I think you will like it also to do some validation for your ghost box and to use your K2 meter also. This simple mod of tapping the audio, I'm going to have a video of that. It's very simple to do, and then you just use any kind of a Bluetooth amplifier in the line-in mode as your amplifier. Very simple setup and very effective. So I hope you go ahead and give it a try and build one of these for yourself, and let me know how it all runs and how it all works for your team. Thanks for watching.